Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Soorya, your chemistry faculty from Infinity Learn. Hi Arush, good evening, welcome to the session. And I hope I'm perfectly audible. Okay, today in this session we are going to discuss the fourth chapter previous year questions, right? Our fourth chapter is carbon and its compounds. We have already completed the chapter. And here we are going to discuss some of the questions which is repeated in the previous year. Okay, fine. So let's directly move to our first question. Read the question carefully. This is the question asked from CBSE 2020. So as we already know, carbon and its compound means carbon, we have already seen that carbon is one of the element which is having the atomic number of 6, and they are forming different compounds because of their tetravalency or the catenation property. So here the question is based on that. Assertion is given here, carbon has a strong tendency to either lose or gain electrons to attain noble gas configuration. And the reason is given here, carbon has 4 electrons in its outermost shell and has the tendency to share electrons with carbon or other elements. So that will be the answer. Are you sure option D is the correct one? Yes, option D is the correct answer. Assertion is false here, but reason is true here. So what will be the reason behind that? Why assertion is false here? So as we already know, right, carbon is having the atomic number of 6 here. So I will write it here. Carbon is having the atomic number 6 here. So 2, 4, right, that will be the electronic configuration. If they are losing 4 electrons, they will be forming C4- ion, right? But it is not possible. Right? If they are losing 4 electrons, there will be a strong attraction between the 6 protons present inside the nucleus. So it is not possible to lose the 4 electrons here. Then if they are accepting 4 electrons, right? If they are accepting 4 electrons, if they are accepting 4 electrons, they will be forming total 10 electrons, which means that is also not possible. So we can say that in terms of, yes, in terms of force also we can say that it cannot lose or gain electrons, it can only share the electrons. That's why they are forming the covalent compounds. Clear? Okay, I hope it is clear. Can we move to the next question? Here is our second question. Carbon compounds, 4 choices are given here. First choice is they are good conductors of electricity, and second one, they are bad conductors of electricity, and third one, they have strong force of attraction between their molecules, and last one, they have weak force of attraction between their molecules. So we just want to identify the correct choices according to carbon compounds. Read the options carefully. Are you sure option D is the correct answer? So option C is the correct answer. Whenever we are discussing about the conductors of electricity or discussing about the properties of carbon compounds, I have already mentioned that carbon compounds are poor conductors of electricity, right? Or they are bad conductors of electricity, because they are, in the case of carbon compounds, they are forming by the sharing of electrons. There is no any free ions are present, right? So that's why they are poor conductors of electricity. One exceptional case is there in the case of graphite, which is the allotrope of carbon. Is that clear, Arush? Is there any doubt now? Yes, the graphite is the only one exceptional cases. Generally, carbon compounds are poor conductors of electricity. Okay, then what about the case of force of attraction? As we already know, in the case of carbon compounds, they are having a weak force of attraction between their molecules. So 2 and 4, which means option C will be the correct answer. I hope you understand. Okay, while discussing about the allotropy, we have already mentioned there, right? Why graphite is considered as a conductor of electricity. So here is the next question. Write the formula of first member of the homologous series to which the carbon compound C4H6 belongs. Okay, conductor of electricity we can define in terms of the free movement of ions, right? But in the case of these covalent compounds, there is no chance for the formation of cations or anions, so that is why they are poor conductors of electricity. Then what about the case of this question? And this question is asked in CBSE term 2, 2021 and 2022. So write the formula of first member of the homologous series to which carbon compound C4H6 belongs. So first we need to identify whether it is an alkene, alkane or alkyne. So this will be an alkyne compound, right? Because general formula is CnH2n minus 2. So if you are taking here, it is C4H8 minus 2, that is again 6 here. So CnH2n minus 2, which means this is an alkyne compound, right? So what is the exact definition of homologous series? The same functional group or the same property, compounds having the same functional group will be having a difference by the CH2 molecule, right? So we just want to identify the homologous series by starting from here, right? So C2H2, first one. Then if you are adding CH2 molecule again, it will be forming C3H4, right? C3H4, then C4H6. Clear? Yes, difference is same with a CH2 molecule. So first we want to identify whether it is an alkene, alkyne or alkene. So here, as we understood from the formula, it has a general formula of CnH2n minus 2, which means it is an alkane group. So how we can find out the homologous series compound? Just take a difference of CH2 here. So C4H6, if you are defining CH2 molecule here, it will be forming C3H4, then again C2H2. Clear? So this is the ethyne, this is propyne, and this is butane. Is there any doubt? Okay, fine. Now we are moving to the next question. So this is again the question based on the homologous series. So this part is very important. At the same term, I mean CBSE term 2, 2021-22, they asked again. The molecular formula of two alkynes A and B are given here. One is CSX2 and other one is C3Hy. We need to identify the values of X and Y. Then write the name of the compound A and B here. Read the question carefully. These are alkynes with the general formula. A formula is given here CXH2 and C3Hy. We need to identify the values of X and Y. The one point you have to keep in mind that if you want to produce any double bond or multiple bond between carbon atoms, at least 2 atoms should be present there. So we don't have any homologous series with a carbon number 1 over here. Clear? So 2 alkanes, right? Alkynes A and B over here. In general, the alkanes will be having the general formula CnH2n minus 2. So if you are comparing here, it is CXH2, right? So in order to find out the value of X, we need to solve from here. So if you are solving from here, let's take from here. From the formula, 2n minus 2 is equal to 2, right? Is there any doubt? This is the general formula for the alkene CnH2n minus 2. Here the first compound is given as CxH2, which means that 2n minus 2 is equal to 2. So from that we can identify the number of X is equal to n over here, that is equal to 2. So what will be our first compound A? The compound A will be C2H2 and the value of X is equal to 2 over here. Then how we can solve the value of Y over here? This is our compound, right? CxH2, which means that that particular compound contains 2 hydrogen atoms. So according to our formula, 2n minus 2 will be equal to 2 over here. That is why we are equating 2 over here. Is there any doubt now? And what about the next compound? Similarly, if you are taking here C3Hy, right? So 2n minus 2 will be the value over here, or X is equal to X or n is equal to 3 over here. So 2 into 3, 6 minus 2, that is equal to 4. So the value of Y is equal to 4 over here. What will be our next compound B? That is equal to C3H4. So this is ethyne and the compound B is propyne. Is there any doubt now? So this is very important question. You can expect this type of question in your board examination. So can we move to the next question? So the next question is based on the structure of a particular compound is given here. While discussing about the hydrocarbons, we have already mentioned, right? Alkanes and alkenes are the hydrocarbons. These hydrocarbons are formed by mixing carbon and hydrogen only. That's why we are taking hydrogen over here. Arush, is that clear? Now how we can draw the structure of chloropentane? We have already seen the IUPAC naming of the carbon compound. So from that you can identify the number of carbon atoms here. This is chloropentane, which means that it will be containing, what is the total number of carbon atoms here? Yes, 5 carbon, right? So pen stands for 5 carbon over here. So I will be taking the longest chain as 5 carbon here, right? Then one substitute is given here, chloro compound. Chloro compound means chlorine is attached to any one of the carbon here. Especially there is no any mention of position of chlorine here, so we can assume that there will be attached to the first carbon, right? First carbon either this side or this side is possible, right? Now we need to balance the valency of carbon by adding hydrogen atoms here. So if you are taking here, this will be forming 3 hydrogen, right? So this is again 2 hydrogen, here 2 hydrogen, here again 2 hydrogen, and here 2 hydrogen, right? So this is the structure of chloropentane. What we need to do first identify the longest chain. Here it is pentane. Pen stands for 5 carbon atoms. So draw the 5 carbon chain over here, then put the substitute over here. This is chlorine here, so I am putting chlorine over the first carbon because there is no any mention for the position of chlorine here. So it will be first carbon, it will be attached to the first carbon. So we need to balance the complete valency of carbon by adding hydrogen atoms. Clear? There is no necessary to find out the branched chain here. You can draw the structure like this also. So if you are drawing the structure here, if you are taking this condense the structural formula, it will be CH3, CH2, CH2, CH2Cl. There is no necessary to become the chlorine in the branched chain. Here is the next question, again the assertion reason type question. Assertion is given here, following are the members of a homologous series CH3OH, CH3CH2OH, CH3CH2, CH2OH. And the reason is given here, a series of compounds with same functional group but differing by CH2 unit is called homologous series. We need to identify whether the assertion and reason are true or false and if it is the correct explanation or not. This is the structural formula. And this is the condensed formula. And this is the molecular formula. Arush, I hope you understand now. So what about the answer for this question? Yes, option A, right? So option A is the correct answer. Both assertion and reason are true and R is the correct explanation of the assertion. So as we already know, the homologous series are the series of compounds having the same molecular formula. Same molecular formula or the same functional group and similar properties but differ by the CH2 unit. So reason is again true. So reason is again true over here. Then what about the case of this one? These are the homologous series of the alcohols, right? OH group means hydroxy group. These are known as the alcohols. So CH3OH means methanol. This is ethanol. And this is propanol, right? So what is the difference here? Differing by CH2 units. So these are the homologous series of alcohols. So our correct answer will be option A because both the assertion and reason are true and these are the correct explanation. So here is the next question. Write the name and structures of aldehyde and ketone with molecular formula C3H6O. Read the question carefully. We need to identify the name and structure of the aldehyde and ketone with the same molecular formula C3H6O. So what will be the name of aldehyde with formula C3H6O? So it is understood that they will be containing 3 carbon atoms. So what will be the word root? It will be prop, right? So if you are having aldehyde as a functional group, the name will be or suffix will be Al, right? So this will be propane plus Al, which means propanol. Then what about the case of ketone? They will be having the C double bond of functional group and their suffix will be propanone. Suffix will be ONE, or for the 3 carbon compound this is propanone, right? Now we need to draw the structure of these compounds. So if I am starting from the propanol, 3 carbon, right? So 3 carbon. Out of them, 1 carbon is the aldehyde compounds. This will be CHO. Now we need to balance the valency, right? So this will be CH3 here and this is CH2 here. So this is the condensed formula CH3, CH2, CHO. Any doubt? Now if you are checking the molecular formula, you can see that this will be C3H6, right? C3H6O. Then what about the case of propanone? Again 3 carbon compound. Ketone compound means they will be having the functional group of C double bond. It will be always in the middle position, right? So this will be CH3, C double bond O CH3. This is known as propanol. Again, the molecular formula will be C3H6O. The first one is the aldehyde compound, functional group will be CHO, and this is a ketone compound, functional group will be C double bond O. Okay. Here is our next question. This structure, right? This is again the condensed structure of the propanol or the acetone. Both of them are the condensed formula. If you want to write down the structural formula, you just want to identify all the bonds over there. So here is the next question. Draw the structure of butanoic acid. Yes, Aisha, you are correct. CH3, CH2, CH2, COH, right? Okay. So as we already know, butanoic acid means they will be containing 4 carbon atoms. Word root is but here, so 4 carbon atoms. So 1, 2, 3 and 4. Then what will be the functional group here? It is oic acid, right? Oic acid means it will be carboxylic acid. So the functional group will be COOH, which means that out of 4 carbon, one of the carbon will be carboxylic acid group. So if you are doing here, it will be COOH, right? Now we need to balance the valency of carbon atoms by taking complete hydrogens here. So it will be CH3, then CH2, CH2, COOH. So this is the condensed formula for the butanoic acid. So this is the latest question from the CBSE 2023. So to draw the structure by using the IUPAC name is also very important. Is there any doubt? Hi Ankush. Now we are moving to the next question. Draw the structures of propanol and propanone and name the third homologue of alcohols and aldehydes. These are 2 sub-questions. First you need to answer the first question. Draw the structures of propanol and propanone. Arush, now check here what is the valency of carbon. How it is balanced here. In the case of COOH group, the oxygen will be forming a double bond with the carbon atom and OH will be forming single bond. So this will be total 3 bond and the remaining bond will be formed with the neighboring carbon atom. Okay, what is the structure of propanol? CH3, CH2, CH2, yes, CH3, CH2, CH2OH, right? So as we already know, okay. Again 3 carbon compound, which means 3 carbon is present here. What is the functional group here? Alcohol means OH will be the functional group, so it will be forming OH over here. Now it will be CH3, CH2, CH2OH. So this is the propanol. And propanol, as we already discussed in the previous question. So if you are writing here again, it will be CH3, 3 carbon compound. One is the functional group C double bond, or this is again CH3. So this is propanol, and this is propanol. Then what about the second question? Name the third homologue of alcohols and aldehydes. Arush, I didn't get your question. Then what about the second question? If you are drawing the second question here, we need to identify the third homologue of alcohol. So alcohols, as we already know, the first compound will be CH3OH, right? CH3OH. Then CH3CH2OH. CH3CH2. CH2OH, right? So this will be the homologues of the alcohols. This is methanol, this is ethanol, and this is propanol. So propanol will be the third homologue of alcohol series. Then what about the case of aldehydes? Which one is the first homologue of aldehyde series? So in the case of aldehyde, as we already know, there is a first aldehyde with carbon number 1 that is known as a formaldehyde or methanol, right? Okay. In the case of carboxylic acid, there is already carbon is present, right? There is already carbon is present. That's why we are giving the name to the, giving numbering to the particular carbon in the case of carboxylic acid. But in the case of OH group, there is no any carbon atom, right? I hope you understand what is the difference there. So the main point you have to keep in mind that if you have the functional groups like carboxylic acid or aldehyde or ketone, these carbon will be identified as these carbon will be numbered in terms of the word roots over there. It will be included in the total number of carbons. Arush, I hope you understand now. Okay, 1 second. So butanoic acid means total 4 carbon atom is present. So here, in terms of if you are having carboxylic acid, aldehyde or ketone group, that carbon should be numbered along with the total number of carbon atoms. So that is why we are putting 4 carbon here. The 4th carbon should be carboxylic acid here. But in the case of this question, this functional group is OH. There is no any presence of carbon here. That's why we are giving the total 3 carbon. After that, we are giving OH group here. Is that clear? And what about the case of aldehyde here? Aldehyde, as we already know, first one is the formaldehyde or methanol. Then it will be CH3CHO. Then third one is the CH3CH2CHO, right? So propanol will be the third homologue of aldehyde series. Is that clear? Here it is asking about the third homologue of the aldehyde and alcohols. Now we are moving to the next question. Okay. So this is the latest question from the CBSE 2024. 3 sub-questions are given here. Define a homologous series of carbon compounds. The second question is given here. Why is the melting and boiling points of C4H8 higher than that of C3H6 and C2H4? Then why do we not see any gradation in chemical properties of homologous series compounds? So there is a proper definition for the homologous series is already given in your textbook. Just refer from there. We can say that these are the series of compounds in which they will be having the same chemical formula, same chemical properties or same functional group, but they are differ by a molecular unit of CH2, right? Differ by CH2 group. Then what will be the reason for the second question? As we are comparing the melting and boiling point of the C4H8, it is always higher than that of C3H6 or C2H4. Okay, in terms of force also it is fine, but in general we can say that while discussing about the melting or boiling point of the carbon compounds, I have already mentioned that as the molecular mass increases, boiling point and melting point are also increases, right? So if you are taking the C2H4, what is the molecular weight here? C2H4. It is 2 to 612 plus 416, right? 16 AMU. Then what about the case of C3H6? Clear? So as we are comparing here, it will be increased by molecular weight. As the molecular weight increases, molecular weight and molecular mass increases, boiling point and melting point are also increases. So as we are comparing here, it will be C2H4, and for C3H4 there is a difference of 14, right? CH2 molecule difference. This is small correction in the calculation here. So these are differ by a 14 AMU unit, right? Our question is here, why C4H8 is having more boiling point and melting point than C3H6 and C2H4. Then what about the case of third sub-question? Why do we not see any gradation in chemical properties of a homologous compounds? Because these homologous series having same functional group, so that's why they are having the same chemical properties. Is there any doubt? So in general, homologous series are the series of compounds having a difference of CH2 units, and whenever we are discussing about the case of melting and boiling point of the different compounds in the homologous series, Because of the increase in molecular mass, their melting and boiling point will be higher than that of the previous member in the same homologous series. Then because of the presence of the same functional group, they will be having the same chemical properties. Okay. Here is our next question. So this question is repeated twice, 2023 and 2024. So this question is very important. Draw the two structural isomers of butane. Or what are the structural isomers and write the structures of two isomers of butane. So we have already discussed the isomers, right? Isomers are the compounds having same molecular formula but different in their structures. So if you are drawing the structures of the butane, as we already know, these are alkyne compounds having 4 carbon atoms, right? C4H10. So first I will draw the longest chain structure. 4 carbon atom is here. So it will be forming CH3, CH2, CH2, CH3, right? Now the next possibility will be the branched chain will be present over there. So 3 carbon atom is present here. One of them will be branched with methyl group. So this is again CH3, CH, CH3. This is known as the 2-methyl propane. So these are the two structural isomers of butane with this molecular formula C4H10. So in the case of structural isomers, there will be only possibility whether they are forming longest chain or branched chain. So in the case of butane, if you are trying to draw more structures, it is possible only 2 structures. One will be the longest chain, other one will be the branched chain. There is no any trick to find out whether they are branched chain or longest chain. So here is the next question. Differentiate between saturated and unsaturated compounds, carbon compounds on the basis of their general formula. So while discussing about the hydrocarbons, we have already seen there will be 2 types of compounds. One is saturated and another one is the unsaturated. In the case of again saturated, there will be only single compound, single bonded compounds. They are known as the alkenes. In the case of unsaturated compounds, there will be 2 possibilities, whether they are multiple bonded. I mean, they will be having double bond or triple bond. So how we can define here? Okay, Ayush, you are almost correct, but there is a correction. Saturated compounds means they are containing only single bonds, right? Single carbon-carbon bonds. So these are known as alkenes, right? Alkenes. So what is the general formula of alkenes? It will be CnH2n plus 2, right? So examples are CH4, C2H6 and so on. Then what about the case of unsaturated carbon compounds? They are containing either double bond or multiple bond. If they are containing double bond, they are known as alkenes, right? General formula CnH2n. Example is equal to C2H2. Then if they are containing triple bond C, these are known as alkynes. General formula is CnH2n minus 2, right? So it will be C2H2, C3H4. So no need of any confusion here. If you are having this saturated compounds, they will be containing alkanes only. Unsaturated compounds mean they will be having double bond or triple bond. So these are alkenes and alkynes. Okay. I hope you understand. Okay, here is the next question. The question is based on the structure of the number of single and double bonds present in a molecule of benzene. So what will be the structure of benzene C6H6? So if you are drawing the structure here, as we already know, they will be containing 3 carbon atoms, right? So out of them, alternate bonds are double bonds, right? So this is the structure of benzene. C6H6, right? This is the structural formula of benzene, or otherwise it will be similarly written as, clear? This is the benzene. So what is our question? We need to identify the total number of single bonds and double bonds here, right? So single bonds means total here 1, 2, 3, 4, 5, 6 and total 3 over here, right? So total 9 single bonds and 3 double bonds. So what will be the answer? Option B will be the correct answer. 9 single bonds and 3 double bonds. Is there any doubt? This is the general structure of benzene molecule C6H6. While you are drawing the structure, you can say that there will be alternate double bonds are present in the case of benzene molecule. So total 9 single bonds and 3 double bonds are present in the case of benzene molecule. Here is the next question. So towards the end of the chapter, we have already discussed 2 carbon compounds. One is ethanol and another one is the ethanoic acid. We have already seen many reactions based on the ethanol and ethanoic acid. So here is the question based on the reaction of ethanol. So longest chain and branched chain, as we already know, right? So ring strength means generally it will be cyclopropane, cyclobutane, cyclopentane. So from your knowledge, you can identify the where it is found in this ring structure or not. This is the example of the cyclopropane. So what will be the question here? Why is the conversion of ethanol to ethanoic acid is an oxidation reaction? And name the oxidizing agent used in this particular conversion and write the chemical equation for this oxidation reaction. Okay, while discussing about the reaction of ethanol, this is ethanol, right? CH3, CH2OH. So if you are taking either alkaline KMNO4, I mean alkaline potassium permanganate, it will be forming ethanoic acid, right? CH3COOH, ethanoic acid. So this process is known as oxidation. So as you can see over here, this is a addition of oxygen, right? Addition of oxygen means these are the oxidation reaction. This is oxidation reaction. You can use either alkaline KMNO4 or acidic K2Cr2O7. Is that clear? So this is the case of oxidation reaction of ethanol. Whenever you are taking either alkaline KMNO4 or acidic K2Cr2O7, you will be getting ethanoic acid as the product. So what you are observing here, it will be adding oxygen. So addition of oxygen is known as the oxidation reaction. So you need to mention here whether you are taking alkaline KMNO4 or acidic K2Cr2O7, potassium dichromate. So according to your syllabus, you just want to identify the structure of benzene only. So benzene is the structure I have already mentioned there, right? These are the unsaturated ring structure. Here is the next question. What happens when ethanol is heated with excess concentrated sulfuric acid at 443 Kelvin? Write the chemical equation for the reaction stating the conditions for the reaction. Also state the role played by the concentrated sulfuric acid in the reaction. This reaction is very important. Now the previous reaction is not esterification. Esterification, as we all know, whenever ethanol and ethanoic acid reacted together, they will be forming an ester. So that reaction is known as the esterification. This previous reaction is already a simple oxidation method to produce the ethanoic acid from ethanol. So what about the answer for this question? This is very important reaction for the ethanol, as we already know, whenever you are treating ethanol, right, CH3CH2OH, heating at a temperature of 443 Kelvin by using concentrated sulfuric acid, right? So what it will be forming here? Here the dehydration happens. Dehydration means a water molecule is released from here. So you will be getting an alkene here. The alkene formed here is ethene. So what is the role of this concentrated sulfuric acid? These are act as the dehydrating agent here. This reaction is very important. Here is the next question. We have already mentioned the reaction in the concept classes. So what you are forming here, one of the OH group is breaking from here and one hydrogen is breaking from here. So that's why they are forming the double bonded carbon atom here, carbon compound here. Here is the next question. A spatula full of sodium carbonate is taken in a test tube and 2 ml of dilute ethanoic acid is added to it. Write a chemical equation for the reaction and suggest a method of testing the gas liberated in the reaction. Sodium carbonate, as we already know, right? Whenever we are treating the ethanoic acid in presence of any of the carbonate, it will be forming CH3COOH. When it is treated with Na2CO3, they will be forming CH3COONA, right? Sodium ethanoate plus carbon dioxide plus water. Clear? So this is the reaction here. This is sodium ethanoate. So this is a method of testing the gas liberated in the reaction. Carbon dioxide is the gas liberated here in the reaction. So when you are treating this particular carbon dioxide gas with the lime water will be turns milky. Yes, turns lime water milky because of the presence of carbon dioxide. Sodium acetate is the common name and sodium ethanoate is the IUPAC name. Both are similar in terms of IUPAC in common name. Here is the last question. You want to test for hardness of water, but hard water is not available in your laboratory. Which of the following compounds may be dissolved in pure water to make it hard? So we have already discussed the hardness of water. Detergent also we have already discussed. So here how we can form the hard water by mixing any of the salts with the pure water. So what will be the answer? So what is the hardness of water? Whenever you are having the water which is containing magnesium or calcium salt, right? Magnesium or calcium salts present, these are forming hardness of water. This hard water does not give lather or form with the soap, right? So here the most common examples are sulfate of magnesium and chloride of calcium, because these are magnesium and calcium salts, right? So option B and C are the correct answers here. Is there any doubt? Now sodium salts, they are formed by the magnesium or calcium salts. Commonly they are sulfides, bicarbonates or chlorides. And this will be magnesium sulfate, magnesium bicarbonate or magnesium chloride. Similarly, calcium sulfate, calcium bicarbonate or calcium chloride. They will be giving the hardness of water. Okay, you will be getting options by choosing whether it is A, B, B, C or so on. I am not included the options given here. Okay, this was last question from the previous year question discussion from the carbon and its compounds chapter. I hope you enjoyed the session. So there is a general reminder about the SCORE examination. As we already know, Sri Chandra Academy is providing you an opportunity to attend the national level of examination, national level of scholarship test examination. So it will be conducted on September 28 and October 12. So September 26 is the last day to register the examination. As we already know, more cash rewards are given here as a part of this examination. It will be applicable for the students from grade 3 to 12. The link will be provided in the description. You can register now. If there is anyone missed to register the examination, you can register now. Okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, share this particular session to your friends and subscribe our channel. If you need to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting the session PDF after all the classes there. So I think we can wind up the session for today. Thank you so much all of you. See you in the next class. Bye bye.